Hi everybody. Welcome to the Kentucky 4-H Virtual Experience. Today we're going to concentrate on SET or Science, Engineering, and Technology programs. My name is Torey and I am an Extension Specialist for 4-H Youth Development with the University of Kentucky College of Agriculture, Food, and Environment Cooperative Extension Service. The activity that we're going to do today is from the 4-H Electric Excitement Curriculum, Book 1, The Magic of Electricity. The activity is called Control the Flow. And in this activity, you're going to learn a little bit more about how a switch helps control the flow of electricity through a circuit. You're going to make your own switch, and then we're going to talk a little bit about different switches that are used for different purposes. As we start our activity, I'll show you some of the things that you'll need to gather up and have on hand in order to do this activity. And then we will make our own circuit with a switch in it. So, let's get started. As we start our activity, some things that you'll need to have on hand are a D-cell battery holder, a D-cell battery rated at 1.5 volts, a couple of paper brads, a paper clip, a lamp holder with a small 1.5 volt lamp in it, index cards, a small Phillips screwdriver, a pair of needle nose pliers, and a hole punch. One of the first things we're going to do is we're going to put a couple of small loops with our needle nose pliers in the end of our solid copper wire. Now this solid copper wire is actually doorbell wire that I obtained at a local hardware store, and it's very small low voltage wire that you can use for activities like this using D-cell or C-cell batteries. So what we want to do is we want to put a small loop in it like this, and in the other end we want to put another small loop in it like this. Then we're going to take one of those small loops and attach it to one side of our lamp socket or around one of the screws, and we may have to bring that screw out just a little bit to get our wire underneath it. And you're going to notice that as I do this, I looped the wire in the direction the screw is going to tighten. That actually tightens the wire down underneath the screw and will not push it out. I'm going to take the black wire end of my battery holder and I'm going to put it on the other side of the lamp socket with the bulb in it, the same way as I did the wire on the opposite side. I'm going to make a little loop in it and I'm going to put it underneath the screw in the way that the screw would tighten down. Like that. And then I'm going to tighten it so it's snug. That way I've got both of those wires attached. Now what our idea is to do here is to make a circuit. We could actually hook these two together. Let me put the battery in and show you how that would work. We could touch the two red wires together and you can see the light comes on. But to make it a little more convenient or functional, we would like to have a switch inside of this circuit. So I'm going to make a small loop in the red wire coming off the end of my battery holder. And I'm going to take one of my paper brads. This is going to be, the index card will be the holder for our switch. And I'm just going to punch a hole in the index card with my hole punch. Then I'm going to take my paper clip. Actually, I'm going to take my red wire coming off my battery holder first, wrap it around the paper brad like so. I'm going to put the paper brad through one of the loops on my paper clip, and then put that assembly through the index card and spread the tabs out on the paper brad. So that way I have a wire that is touching my paper clip that is secured by the paper brad. Then what I'm going to do is take my hole punch, go to the other end of the loop on my paper clip, and I'm going to punch another hole. Through this hole, I'm going to secure the wire, and you can do this with your needle nose pliers. Secure the wire that is going to my bulb or to my lamp socket on the other paper brad. Then spread the paper brad tabs out, just like I did on my other one. And if you would like to with this, you can secure these tabs underneath with a piece of tape, but that's what it's going to look like on the back side. And now, since our paper clip is metal, our paper brads are metal, and our wires are metal, all of these are conductors of electricity. Our index card is not a conductor, it is an insulator, and you'll notice that the wires have a rubber coating around them. Those are insulators too and won't let electricity flow through. So now what we do, we put our D-cell battery inside our battery holder, and the wires are not touching, so the circuit is not complete. But to make that circuit complete, we'll move our paper clip down, touch the paper brad, and you notice the light comes on. So we have created our own circuit and put a switch in it using a paper clip as our contact point for the switch. Paper clip is down, circuit is closed, the light burns. Paper clip is up, circuit is open, the light does not burn. If you'd like to make the process a little easier and not have to worry about using tools as much, you can actually do this same activity using alligator clip wires if you have them available. You can usually find these at a hobby shop or something like that, maybe an electronics store. But you can use these to clip to your wires and to your paper brads and to your lamp socket, so you don't have to worry as much about using tools. Either process is very acceptable to use just as a learning process, because this in particular would not be considered a state fair project. This is one of the tools that you would use to develop your state fair project in learning a little bit more about electricity. There are several different types of switches that can be used for different applications. The switches on this side are used for direct current applications or with batteries. The switches on this side are used primarily with alternating current situations, like wiring a house or a farm or some other type of structure or building. The two types of switches that we have here, just to give you some information, this is a push button switch. It is called a momentary switch. You push it and hold it, it allows current to flow through. You let go of it, it stops the flow of current. So that's kind of handy if you're needing something to be on for just a second, or you're needing to flash a light or something like that. You can push it and it'll provide a momentary current flow until you release the switch. This particular switch is used a lot in lab type activities for low current electricity. It's called a knife switch. And you see it has two terminals on it, one to hook your inlet wire or your positive wire from, and one to hook your negative wire from. So if the switch is open like this, there is no connection between this side for positive and this side for negative. But if you close the switch, both of these sides are now connected, because you can see underneath everything is tied together. So simple knife switch, all it does is open and close a circuit to allow electricity flow. These two types of switches you will probably see either in your house or in your office or something like that. This particular one is called a single pole, single throw switch. Just in looking at one in a box on the wall, you will be able to almost immediately tell it, because it does, on the switch itself, have two words, on and off. 9 times out of 10 when you see a switch like this, it is a single pole, single throw switch, and it is designed to turn a light or an outlet or some mechanism off and on from a single location. You look on the side, it's got 2 brass screws on it. These brass screws are for the hot wire. So as you would hook up a circuit, wire comes in here, wire goes out here, and if the circuit is off, no electricity will flow between the two. If the circuit is on, that closes it and electricity will flow. Now this one is just a little different. This is called a 3-way switch. And if you'll notice, hold it up, it does not have off and on it. It is just designed to interrupt the current flow from 2 locations within a house or an office. So if you wanted to have a light or a switch that you are able to turn on from one entrance door and then turn off from another entrance door, this is the kind of switch you would use. Notice on one side there are 2 screws, and on the other side there is only 1 screw and then a ground screw. This is designed to have electricity come in through this, and then 2 lines go out to another one of these switches, and that will allow the circuit to be broken from 2 different locations. So if you come in one door and turn your light on, you go out another door, there's another one of these types of switches there, you could turn your light off. Control a light or a circuit from 2 different locations coming into or out of a room. As we wrap up our control the flow activity today, review a little bit. What did you learn about switches? What is a switch? What does it do? How does it stop or start current flow within a circuit? What are the different types of switches? How are they used? And hopefully some of these things will help you as you start to develop your 4-H electric project, or maybe even a 4-H electric project state fair project. Now each one of these individually is not a state fair project, but again, they are going to give you the skills that you would need to help you develop a state fair project. Thank you for joining me today for the Kentucky 4-H virtual experience focused on science, engineering, and technology. For more information about the 4-H SET program, please check out your local University of Kentucky Cooperative Extension Service.